the names are very intuitive here that we're dealing with, right? If I'm looking at a unit vector, I'm thinking of something that's 1 unit. What's this 1 unit that I'm thinking of? Well, it's actually 1 unit of magnitude, right? So it's a magnitude of length 1. Let's look at an example. Right? You look at something like this, yeah? All right, so let's start from back here. Okay, so this idea of like a unit vector, right? I'm thinking about a vector that has length 1. Yeah, and GeoGebra is very useful for these visualizations because it tells you very clear what's going on. If I look at A and B right now, they're both length 1. These are unit vectors. They have length 1. That's an example. What's another one with length 1? Where could I go? I could go that way, right? These both also have length 1, right? And any of these ones that go to 1 are going to be length 1. What if I go here? Would that also have length 1 for vector A? Let's have a look. No, it's a bit longer, right? 1.41 or square root of 2, right? But length of B, they maintain that unit length of 1, right? So this is what we call the unit vector. Every vector has what we call a unit vector. There's a way to convert it from thinking about, okay, if it's a particular length here, I can take it back so that its length, this vector here, this red vector is always going to be 1, right? Let's go to, for example, 2 now, right? And it doesn't matter how long I can make vector A. I can go anywhere I want. But you can see that vector B, it maintains its length around there, okay? So I guess the question is, if you want to think about it, how do you actually do that? How do you go from some vector that's like length 3, and how do you shrink it down to length 1? I mean, if it was just a number, how would you do it? You just divide by 3, right? And the principle is the same, yeah? What we want to do is, we want to see, okay, why did you divide by 3, by the way, Matt? Yeah, what does 3 represent here? It's the magnitude, the length, okay? So essentially the idea is, if you have any vector, how do you go back to its unit vector? And remember, unit vector is saying something is length 1. The idea is that we need to divide by its magnitude, whatever that is, okay? So it doesn't matter if it's like going back to this one, right? Bang, right? This idea here is, okay, what's the magnitude of this? Well, it would be the square root of 1 squared plus 1 squared, which is the square root of 2. Okay, so dividing this by root 2 would give me that. And if you put in your calculator, 1 over the square root of root 2, let's have a look. Yeah, hopefully the prediction works out. 1 over the square root of root 2. Okay, we do in fact get 0.71, right, when you round it. Right? So this is the idea behind a unit vector. Okay, the way we find it, going back to this, the idea is that, okay, so a few things. It's a magnitude of length 1. It maintains the same direction, as you saw. Remember, I dragged around the A everywhere, and it still kind of stayed the same way. But the kind of calculation that we do for this, and the notation that we use, I don't know why there's that symbol there. That probably shouldn't be there. Get rid of that. Dude, now the tildes are in the wrong... Oh, man. Yeah,
you put the time there.
Yeah. I don't know. There was probably a reason. I'm probably going to remember it later. But notation, right? U hat is our notation. And then think about what this is saying, right? This is saying, okay, you take your vector u and you divide it by its magnitude. That's the idea, okay? What do we define the unit vector as, Carl? Remind me again. Good, okay. And so a vector that remains in the same direction as the original one. And so if we have this notation here, u hat, right? The unit vector u hat, that's how you pronounce it, right? Has the same direction as u, the original vector, right? But has a magnitude of 1. Great question, Matt. Is there a point? Think about this, right? In mathematics, we're always kind of obsessed with going back to like a single unit. A great example is like ratios, right? When we're looking at like, 3 to 2 or whatever, right? Or if I've got, 150 kilometers in 2 hours. We're always obsessed with this unit rate, like how much are you traveling per hour? Or what would the ratio be from 1 to something, right? So this idea of a unit vector shouldn't come as a surprise, because when you go back to a single unit or something, it allows you to answer other types of problems, right? So for example, with the unitary method, if I go back to 75 kilometers per hour, it's much easier now to find, how long is it going to take you to travel 5 hours, right? And so in a similar idea, this idea of a unit vector is going to allow us to answer a particular type of problems, particularly when we look at something called the projection of vectors. We really want to be going back to that singular unit amount. So that's a bit about why, but how do we actually do it, right? So we know what it is. We know that it has the same direction of u, but it has a magnitude of 1. And we said there's actually a formula to calculate that. What was that formula? The linear u. I haven't heard that one before, but yeah. So the u hat, or the unit vector, is equal to the original vector itself, right, divided by what's linear u? What's the magnitude of u, okay? So let's just kind of understand why exactly this is the case, right? Because if you take, right, as a simplistic example, if you take, ignore that. Why does it not work? Yeah. If we take, what was the one we had before? We had like 3, right? If we take this vector u, and I want to go back to its unit vector, so the one that's a singular, a magnitude of 1, right, u hat. The idea is that, I can just take whatever vector this is and then divide it by 3. What vector is this as a position vector? Yeah, that's it, was it? 3, 3, 0. Why 3, 0? Because you're in 3 across, 0 up, right? So it's like your coordinates, yeah? And so if you think about it, okay, well, let's use this formula now. U hat would be u divided by the magnitude, right? And so when you're writing this out, a few different ways you can write this out, yeah? If you're dividing it, we wouldn't place like this vector on top and then divide it like that, right? The idea with multiplying and dividing by numbers, because this is a number here, if I want to divide it by 3, that's the same as multiplying by 1 over 3, right? So I can write this as maybe 1 over u, magnitude of u, times the vector. And so I'm thinking, okay, well, the magnitude of this, that's just the length. So that'd just be 1 over 3 times this vector here. And so like I said, we need to define what does multiplication look like when we're talking about scalars, because that's a scalar and this is a vector. The idea is that you're just multiplying the horizontal and vertical components, right? So if I multiply this by 1 over 3, that just gives me 1, and that's just going to be 0. And that is, in fact, 1, 0, right? So can you see how that works? This is the idea of how this formula naturally gives us this. We're dividing by the magnitude. Kyle, what was the one in your question there? The u is not 3, 0, right? What is u in this case?
2, 1.
2, 1. Okay, sweet. So 2, 1. So now if I have 2, 1 here, I guess let's say that's A, B. Emily, what's the magnitude for this guy?
2 over 5?
Yep. And again, like if you could, you don't have to always just write out, the diagrams and everything. If you're happy to just kind of do it based on that, square root of 2 squared plus 1 squared. So we've got that. And so if I want to find u hat now, Joel, what do I have to do?
Depends on which way you want to write it.
Okay, which way do you want to write it?
Okay. I guess the easy way to follow is having 1 over
Yeah.
root 5
Okay,
times
cool.
the
Yep. Okay, in a few ways you can write this now, right? You can leave it as 1 over square root of 5 and then just outside of 2, 1, so it's almost like a coefficient. Or you can also actually put it inside the vectors themselves. So they'll do both generally. I can't remember which one they do more in your textbooks, but just be aware that, yeah, both of these are correct as well, okay? Yeah. So this would be the unit vector that we create, because we're saying, okay, I want to go back to the magnitude of length 1, and if you actually found the magnitude of this, you would find that it is equal to 1, okay? So that's the idea of a unit vector.